Over 500,000 people worldwide use these devices called cochlear implants to hear. They enable people with severe to profound hearing loss to regain a sense of hearing, or for the congenitally deaf to hear for the first time. As a neuroscientist, I'm interested in how the brains of cochlear implant users are able to undergo compensatory plasticity to first experience this period of sensory deprivation and then later to undergo hearing restoration through devices like this. fNIRS, or functional near-infrared spectroscopy, is a great neuroimaging tool that enables us to measure changes in blood flow and oxygenation to tell where neurons are more or less active. By wearing a cap that has 16 light sources and 23 detectors, we're able to measure activity across 52 locations on the brain. Unlike other neuroimaging techniques such as EEG and fMRI, this infrared light-based technology is both safe to use with implants and it isn't affected by either the electrical or magnetic components of CIs. I'm particularly interested in how the brain integrates information across multiple senses to understand speech. We know that even with typical acoustic hearing, listening and noise can be made much easier by being able to see a speaker across the table. As an example, try listening for a woman saying a number in this really loud background noise. Now, let's listen to the same recording, but add in a visual aid. For cochlear implant users, auditory perception is always going to be noisy, even if they're in a quiet room. This means that they may be experiencing this idea of audiovisual benefit no matter what the listening conditions are. In a series of experiments, we're adding progressively louder background noise and testing how many words people can correctly identify when they're just listening, when they're just lip reading, or when they're doing both at the same time audiovisually. For my PhD thesis, I'm using fNIRS to investigate whether cochlear implant users develop greater cortical processing for audiovisual speech perception in comparison to normal hearing control subjects of the exact same age. My hope is that this research will lay the foundation to better incorporate visual training in hearing restoration, as well as functional neuroimaging in clinical assessments.